Okay, ladies and gentlemen, I have decided that your Unit 2 test is going to take place on Friday next week because it's either that or I send you home to forget everything over spring break and give it to you when you come back. You all think that, and yet most people will do poorly. And it will be like, oh, I'm not ready. I need more time. And I'll be like, you had 2 flipping weeks. And then like, no, I forgot everything. I don't understand anything. Ah. So Unit 2, but we're not going to get through everything because we only have a week and a bit. All right, so we're going to only test on what we get up to, which I imagine will probably be 2.4. Okay, so 2.5 and 6 will probably not be on the test because we won't have that. So what's going to happen to 2.5 and 2.6? 2.6, I might throw in with another unit. You know what I mean? So I think you're going to hang on to this book after we're done this unit. And if you're like, I'm going to lose it if I take it home, then you're going to leave it here with me. I will put it in a cupboard and I will haul it out for you again when you need it back. Does that make sense? Because that way we can finish what we need to finish. We can do spring break. Over spring break, you're going to be doing some review of grade 9, 10 on the atom. Do you guys remember figuring out numbers of protons, neutrons, and electrons? Okay, so either you know how to do it yourself and you can just go straight to the worksheet and be done, or Tyler DeWitt is going to teach you, okay, and then you can go to the worksheet and do it, and that's going to happen over spring break, okay, and then we can jump into the rest of that unit once we are back. That unit, that little spring break homework, if you do not do it, it will harm you because I'm going to put it in as a lab assignment. So, and we don't do a whole lot of labs, so you can do really well on that just by completing it. Because I'm not going to be like, oh, did you get it right? Because of course you have an answer key. If you want to just copy everything down and not learn any of it, you could do that. It would be a stupid use of your time because if there's something you don't understand, it would be better for you to write a question mark beside it and put a sticky note on that page. And when you came back, you'd be like, oh, I have a sticky note on page 15. What was that about? Oh, Miss Spence, on page 15, could we go over this question? Wouldn't that be smarter than copying from the answer key when you don't understand it? And I will give you full credit for writing a question mark with a sticky note. Yes? Right? I did not understand this and I need help on it. That is full credit. Okay? So does this sound like a deal? It's not huge. The 4 videos are like 40 minutes. Like when you add them all up, there's like 5 videos, 40 minutes. They're about 8 minutes each. And then the worksheet stuff is just like calculating the number of protons, neutrons, and electrons and writing isotope notation, which is like, have carbon, 6, 12, and if it was an ion, maybe 2 plus, even though there's no carbon ions. Yes? And if that is not familiar to you, don't worry, Tyler will teach you. Okay? So that's our plan for the next week and a half, is to get through as much of this unit as we can. So, oh, I don't want to do that, no. Do you have any questions on anything for your quiz tomorrow? Like, were you working through anything and you're like, I don't know why this answer is the way it is? I did want to go here to page, there is one that definitely has a problem with the answer key. On page 45. Page 45. Number 72. The answer should be 2120. The answer key does not say 2120, it says something else entirely. I will put up the worked answer for that later, but that's the actual answer for that one right now, okay? And if you're like, I don't want to do double black diamond questions, then you don't even need to worry about that, okay? So, yes. Huh? Oh yeah, it's negative. Thank you, thank you, thank you. Yes, there should be a negative in front of that. Any other questions? We're feeling good about our quiz tomorrow? Ish. Feel free to stop by tomorrow during Flex if you need some help, okay? All right. In that case, I want to make sure that everybody has one of the sort of ivory colored sheets that you got last day if you do not have one, because let's say you were away. Let's make sure that you get one. Anyone else need one? I can give you an extra if you need one. You're good? Okay, cool. Anyone else? Okay. Today we are going to go on to, where did it go? 2.3C on page 57. So we are looking at converting rates. A rate is where you have one unit on the top and one unit on the bottom. It's something per something else. And so we'll be looking at instances where we are converting the unit which is on the bottom, okay? So for example, we have this little example here, but I'm going to do it over here, all right? And the first thing I'm going to point out to you is that very often it will be written per hour like that. You do not want to leave it like that. You want to rewrite it as 5 kilometers over hours. Because doing unit conversion requires you to know what's on the top and what's on the bottom. And if you leave it like this, 5 kilometers per hour, it looks like everything's on the top, even though it is not, right? The hours are on the bottom, but it looks like they're on the top, and that can lead to, it also makes it hard to read your work. So we're going to rewrite that one. What do you think we should do with the kilometers per hour? Sorry, kilometers per minute. We should do what? We should rewrite it, yes, as kilometers over minutes. So now we have a number that we know. That is our initial quantity. We have the unit we want to convert it into. That is our unknown. And we're not given a conversion factor, so presumably it's something we can either look up on our ivory colored sheet, or we can just know it, okay? So remember, you're going to write it down in the format, my unknown is equal to my initial quantity times the conversion factor. So my unknown kilometers per minute. How many kilometers per minute? My initial quantity, 5 kilometers per hour. So we're going to write that down, 5 kilometers per hour. Then we're going to write times and a line so that we can put something on the top and we can put something on the bottom. Do I need to do anything with the kilometers? No, but I need to do something with the hours and I need it to cancel. What's different though is that the hours right now is on the bottom, so where do I put it in order to make it cancel? On the top, okay? And that means that I need to put my minutes on the bottom, which is really good because that's where I want them. I want them in the denominator, okay? So we have 1 hour for every 60 minutes. We cancel out the hours. We go 5 divided by 60 equals 0.083, repeating. Now, if I'm doing sig figs, 5 kilometers per hour, is that an exact number or an inexact number? Kilometers per hour, think about that. It's a speed. Can you have an exact speed? No, so this is going to have 1 sig fig. How about our 1 hour and 60 minutes? Those are exact because those are defined. So this has infinite sig figs and infinite sig figs. And so now we need to round that to 1 sig fig. So we look to the right and we say that's going to be 0.08. Am I done? No, what am I missing? Units. You guys are so awesome. Kilometers on the top, minutes on the bottom. You could, if you wanted to at this point, write it as 0.08 kilometers per minute. That's the only time when you should be writing it like that is in the final answer, but you can also just leave the final answer like that. That's really good, okay? But if you like, you can do that. Straightforward enough? Okay, we're going to do I'm just going to work through one example to show you what happens if you don't rewrite. Here we have some regular beef, and it costs, this is from a long time ago, $2.89 per pound. What is the cost in dollars per kilogram? This is a little bit tricky because $2.89 per pound could look like a conversion factor. Yeah, you've got 2 units involved there. But that would be good for converting dollars to pounds or pounds to dollars, right? I could use that to convert from pounds to dollars or dollars per pound. Is that what I'm being asked to do in the question? If regular ground beef costs $2.89 per pound, what is the cost in dollars per kilogram? Am I being asked to do either of those 2 things? No, so I'm not going to be using it as a conversion factor. It is actually my initial quantity, okay? So this is our initial quantity here. This is our unknown quantity here. And before I go any further, I should do something. What should I do with $2.89 per pound written the way it is written right now. Yeah, I should put one over top of the other, okay? So I should rewrite it. So I have $2.89 on the top, and I have pounds on the bottom. I should do the same thing with my dollars per kilogram. I should put the dollars on the top and the kilograms on the bottom. Now let's just see what happens if we miss this step, okay? This is a common error that occurs if you don't do that step. So let's just, here it says it's just telling you to rewrite it. Okay, yay, there we are. Here is our common error. What if we took our initial quantity, $2.89 per pound, and we just left it like that? It would look like the pounds is on the top, yes? It looks like it. And it would be a very common thing for a student to do, to then be like, oh, I need to put the pounds on the bottom in order to cancel out the pounds on the top. Hooray, it looks like I've done it. And I would plug in 2.89 times 0.454 equals, and I get 1.31206. And now let's figure out what my unit is. It looks like my pounds cancel out, and what I'm left with is dollars. Oh, this is looking so good. Hang on. Where is kilograms? Kilograms is on the top. So I have a unit of $kilograms. That seems pretty strange, yes? If you get a unit like $kilograms, you can know that you have done something wrong. That's why it always pays to check your units and see what you've canceled and what's left over. In fact, if we were to actually do this the way it really is, and we said, okay, instead of writing per pound, if we put the pound where it belongs down here, you could even see that, oh, the pounds don't actually cancel, right? Now I have pounds times pounds on the bottom, and worse yet, now I have $kilograms per pound squared. And if that is not a unit to give you nightmares, I don't know what is. Okay, so if you end up with something like that, you've obviously gone wrong and you should probably just start from scratch. All right, so this next part of this page just works through that with you, so we can skip on ahead. And now on our next page, page 58, we are back to the original example. And once again, I'm going to go over here to go back to my original example so I can write stuff. Okay. If regular ground beef costs $2.89 per pound, what is the cost in dollars per kilogram? So we're going to need to convert the bottom part of this, not the top part. And we need to convert between pounds and kilograms. Does anyone know the conversion factor between pounds and kilograms if it weren't sitting right in front of you? Is that something that you know? Probably not. Where should you look? On your sheet. So let's go to your sheet. Okay, and let's go here. Pounds and kilograms. 1 kilogram is equal to 2.205 pounds. And you'll notice that this is in the metric imperial, going back and forth between two different units. So what that means is that the 1 kilogram is going to be exact and the 2.205 is going to be inexact and have 4 sig figs, okay? back to our question now that we've looked that up. And I think I wrote this down wrong, 2.205. That should be 2.205 there, pounds per kilogram. So we want our unknown equals our initial times the conversion factor. Our unknown is the dollars per kilogram. Dollars per kilogram. Our initial quantity is the $2.89 per pound. We want to cancel the pounds, and the pounds are on the bottom, so the pounds need to go on the top. And we want to find kilograms, and those are going to go on the bottom because they are on the bottom over in our what we want to solve for. And we can take our number here and we will write that we have 2.205 pounds per 1 kilogram. I also want to point out another error that sometimes people make, and it is the following. What did I just do? I'll do it again. You just don't write your operator. You need an operator in between those two. Another option, if you preferred, you could put it like this, which also means I'm going to be multiplying these two things. It doesn't matter, but you need to tell me you are multiplying them. You cannot just leave it blank. Okay. Another thing, another common error, watch this one. This is exciting. This is just people's brains are just going like a little floofy, right? They're just like, ooh. Toss an equal sign in there. No, it's not an equal sign. It is a times sign. I don't know how the equal sign appears there, but it does more often than you would think. Okay, so just watch out. And that's why every time you write a conversion factor, you should be like, I am going to write times line. And then you've written your times, not an equals, and you've written a line. Okay, and that'll save you a little bit of grief. Let's do the calculation. 2.89 times 2.205 equals, and we get 6.37245. Should I put a box around that? Am I done? No. Okay, I'm not done yet. What do I need to do? I need a unit. My pounds have canceled out, and I still have dollars, and I still have kilograms. So that's excellent. I have dollars per kilogram. Done. Put a box around it. I'll let you think about that while I go and shut the door. So, what do you guys think? Am I done? Should I put a box around it yet? What have I forgotten? Yes. Sig figs. Yes. Okay, so no box yet. Let's do some rounding here. I have $2.89. Is that exact or inexact? That's inexact, so that is 3 sig figs. And I have I've got 2.205 pounds, and that is 4 sig figs. So my answer should have 3 sig figs, which would be $6.37 per kilogram. Now I always hate it when things are in dollars because you're sort of it always makes sense to go to 2 decimal places. The other thing is, it probably is actually exactly $2.89 per pound. I hadn't even thought of that. I've been teaching with this example for like the last 20 years. And if you go to the store and you're buying something for $2.89, oh, yes, for 2.89 cents per pound, it's not like approximately 2.89 cents per pound. The actual mass would be approximate, but we're not doing anything with mass here. Anyway, don't think about that too hard, because I obviously haven't for the last 20 years. Just pretend I said nothing and move on with your life and be like, now I can put a box around it. I have 3 sig figs and I'm done. Okay? All right. Should we do the big bad problem? One big bad problem, and then I'll let you do some practice. All right, so we are now on page 59, and we're looking at some bald eagles. I wish I could draw, because then I would draw like a little bald eagle. There's his little beak, and he's diving, but that's all I can do. There we go. No, their feet come down like this, don't they? Okay, it's getting worse and worse. Okay, we have bald eagle, and he's diving at speeds of up to 100 miles per hour, and that's 100 with a dot. How many meters per second is this? And I'm going to pop over here, because I've got the question written over here. What is the first thing that we should do before anything else in this type of problem? Pardon me? We should make a path, definitely. A path is good, but even before that, yes. That is also good. That is also good. So let's do that, but then there's another thing that we need as well. Okay. So we have 100 miles per hour. What is that? That is the initial. And our unknown is the meters per second. But there was something else that I was thinking of as well. You're going to put the this over that rather than you're going to get rid of the slash, and you're going to rewrite as 100 miles per hour. And we're going to rewrite this as meters per second. So now we have our initial and our unknown, and you're absolutely right at this point. I do want to do a map because this is big and long and nasty. If you can do it without doing a map, that's fine, but you know, we're going to do one. So we're going to start with 100 miles per hour, and we want to finish over here with meters per second. I can only convert 1 unit at a time, so I'm going to have to do something with the top, and then I'm going to have to do something with the bottom. Does anyone know a conversion factor between miles and meters? I don't. So if you don't, that's okay too. Let's look at our chart of common conversion factors and see if there's something useful in there. So we're wanting to get from miles to meters, and so we're going to look in this section that has imperial stuff because that's miles. Do you see miles anywhere? We got some miles. Would it be useful to convert miles into kilometers? Would that get us closer to meters? Yes. Why? Do you know how many meters there are in a kilometer? There are 1,000 kilometers in a meter, and if you don't know that yet, after tomorrow you will, okay? So just bear with me. We will get to all our metric conversions tomorrow, because you'll notice that in this conversion factors that you do not need to memorize, there's not much in the way of metric ones, because metric are all down in the conversion factors you do need to memorize. And we'll learn those tomorrow. But for now, we have, where did we get to? Right, 1.609 kilometers per mile. Let's go back here. So we have a conversion factor that we just looked up, which is 1.609 kilometers per mile. So we are able to go from miles to kilometers. At this point, we're not going to do anything with the hours because we can only deal with one unit at a time. So the miles is going to kilometers. Kilometers can then go to, we want to get to meters. Can we go from kilometers to meters? Yes, we can. So we're going to leave the top alone at this point. Okay. The bottom part, oh, no, we're not going to leave it alone because we do have to go from kilometers to meters. I forgot that. Okay, there we go. All right, so we went from kilometers to meters and we left the hours alone. And now we have made it to where we want to be with our meters. Now we need to convert the bottom part. What could we convert hours into to get closer to seconds? We could convert it into minutes. If you're one of those people who knows how many seconds there are in an hour, you could do this in one step, but we're going to do it in 2 steps. How many steps do we have all together? We have 4 steps. Okay, 1, 2, 3, 4. Every time you have an arrow, you have a step. Again, we want to write down our unknown is equal to our initial quantity. How many conversion factors are we going to be using? We're going to be using 1, 2, 3, 4 conversion factors. So it's going to be times 1, 2, 3, 4. Our initial quantity, or sorry, our unknown quantity, meters per second, that's what we don't know. So we're going to write that here. I don't know how many meters per second. My initial quantity, 100 miles per hour. And one way that you're not going to forget to write down your time signs is to write them in right now. Every time you have a conversion factor, write times line. And we have 4 conversion factors, so we're going to write times line, times line, times line, times line. 4 conversion factors. Now I haven't forgotten any of my timeses. I haven't written any equal signs instead of timeses. So we need to go from miles to kilometers. So we need to cancel out the miles. Right now the miles are on the top, so the miles need to go on the bottom. And that means my kilometers will go on the top. I'm just going to do my units for now. Step 2, we want to go from kilometers to meters. So I want to cancel kilometers. Kilometers are on the top, so kilometers now need to go on the bottom. And that means that what I want to find, the meters are going to go on the top. Boom, kilometers are gone. And look, I have made it to what I want on the top at the very end. So I'm going to stop messing about with the top part, leave it alone, and I'm going to go back and say, oh my goodness, I have hours here on the bottom. I don't want hours, I want seconds. So we are going to convert from hours to minutes. Where am I going to have to put the hours to cancel them out? Right now they're on the bottom. They need to go on the top. And yes, they're kind of far away, but it still works. They can still cancel. So hours on the top, minutes on the bottom. Hours will cancel out. I don't want minutes, I want seconds. Minutes are on the bottom, so now they have to go on the top. And seconds go on the bottom. And now I can go through and say, I know there are 60 minutes in 1 second. No, that's wrong. There are 60 seconds in 1 minute. There's not 60 hours in it. There's 60 minutes in 1 hour. There are 1,000 meters in 1 kilometer. I'm getting them all backwards today. And like I said, if you don't know that one yet, I will teach you a way of memorizing it tomorrow. Okay. And then finally there is 1.609 kilometers per 1 mile. That's the one we looked up. And there's a decimal here that I forgot to write in after the 100. Big decimal so I can see it. That's ugly now. I'm sorry I did that. Oh well. 100 times 1.609 times 1,000 divided by 60 equals 44.6944. Box? All done? No. What do I need to do? Sig figs. Now that I've drawn that great big baseball of a decimal there, how many sig figs in 100 miles? 3 sig figs, because zeros on the right are significant when there is a decimal. How many sig figs in 1.609 kilometers per mile? I have metric and imperial, so that would be 4 sig figs. How about that 1? That's an exact number, so that's going to be infinite sig figs. And now we get into a whole bunch of things which are all definitions. There are exactly 1,000 meters in 1 kilometer. There is exactly 1 hour for every 60 minutes, exactly 60 minutes. And there is exactly 60 seconds in exactly 1 minute. So we really have not very many sig figs that actually matter, because all the infinite ones, we can just ignore them. And we are down to the 3 sig figs and the 4 sig figs, which means we will round to 3 sig figs. 1, 2, 3. Look to the right, and that gives us 44.7. Put a box around it, right? Done. No, units, yes. You should be doing this at the end of every question. You should be pretending that Miss Spence is up here overacting. Am I done? No. Am I done? No. So when you get to the end of your question, you should be like, am I done? No, I'm not done. Okay. So now we have, what is our unit? So everything is all crossed out. The only things that are not crossed out, you can go and find them. We have meters on the top, which has been left alone, and we have seconds on the bottom. So that's going to be meters per second. And now I am done. Is good? Okay. So I'm going to give you some time to practice this. Oh, there's another way to do this. Do you want to see the other way to do it? You might find it easier. If you don't want to see the other way to do it, you can just start practicing on these ones. I will show you the other method because sometimes people find it easier. Method 2. What we do is we convert the top. We convert the bottom. Then we take the top and we put it over the bottom and we divide, which is step 3. So what does that look like? Well, we are still trying to go from 100 miles per hour, and we're trying to convert to meters per second. So the top part is going from 100 miles to meters. The bottom part is going from hours to seconds, and then we will do the division. So let's do the top. Top. I want to find meters, so I don't know how many meters. I am starting with 100 miles. And I'm going to be a little bit quick about this because we've already sort of done this conversion. So we know we can convert miles into kilometers, and we know we can convert kilometers into meters. There were 1.609 kilometers per 1 mile, and there were 1,000 meters per 1 kilometer. So my miles cancel out, my kilometers cancel out, and so the top part of that is equal to 100 times 1.609 divided by 1,000. No, times 1,000. 100 times 1,000 times 1.609 equals 160,900, and my unit is meters. And that was the top. So first we did the top. Now we're going to do the bottom. And the bottom, I want to convert hours to seconds. Okay, I want to convert hours into seconds. How many hours are we dealing with though? How many hours are down in the basement here? 1. So I'm converting 1 hour into seconds. So how many seconds am I going to get? Well, I'm starting with 1 hour. I can convert hours into minutes. I can convert minutes into seconds. There are 60 minutes in 1 hour. There are 60 seconds in 1 minute. And we get 3,600. Hours cancel out, minutes cancel out, and we're left with seconds. So that is the bottom. So step 1, calculate the top. Step 2, calculate the bottom. Step 3, you're going to put the top over the bottom and then divide them. Okay, so we're going to take the top over the bottom and then divide. Oh, I should just get rid of this here. Delete, cut. That's just in my way. There we go. So now we're going to take the top. Step 3 is divide. Oh, not responding. Okay, there we go. No, I want red. There we go. 3. Divide. Put the top over the bottom, yellow over blue. So that is the 160900 meters. And the bottom is 3600 seconds. And sometimes people just leave it there and they're like, oh, I'm done, woo! You're not done because you have not actually done the division, so you need to actually throw those into the calculator. And you get, guess what, the same number as we got before, 44.694. And the units are meters per second. And we still have 3 sig figs because if we go back to all of our numbers, if we look at all of our numbers, the 100 miles, 1.609, 1,000 meters per kilometer, 1 hour, 60 and 1, 60 and 1, all of those have infinite sig figs except for the 100 miles, which has 3 sig figs, and the 1.609 kilometers, which has 4 sig figs. And so our answer would still have to have 3 sig figs, which would give us 44.7 meters per second, and you are done. So if you prefer that method, that also works very nicely. The quiz on this stuff will be on Monday. Okay, so you have a quiz Thursday, you have a quiz Monday, and then I'm very sad to say there will also be a quiz on Tuesday. And the reason it's on Tuesday and not Wednesday is that my block 3 has their test on Thursday. So I need to get their quiz back. So we're going to do metric conversions on quiz on Tuesday. Okay, so quiz on regular unit conversions on Monday, quiz on metric conversions on Tuesday. Wednesday, we're just going to redo quizzes and whatnot, and then Friday is your test. You might want to make some use of flex time next week if you're like, you know, confused about anything, okay? Yes, yeah. So for today, 2.3c, that's pages 60 and 61. And also make sure you're ready for your quiz. On Monday. And then on Tuesday, we're having specifically metric conversions. Okay, so it's exactly like this, but it's going to use the metric conversions that we're going to learn tomorrow. Okay, so we will have 3 days to sit with metric conversions, and then we'll have our quiz on Tuesday, right? Because we got Thursday, Friday, and Monday to deal with metric conversions. So it's not as bad as it sounds. I know it sounds bad, but it's not as bad as it sounds. Yes? Oh, and I should stop recording, because that would be a swift thing to do.